All right, so last time we talked about how to graph functions that were in the form ax squared plus k. Notice the difference today is that we have a term that has an x. So we have a linear term is what we call it. So for that reason, there's a little different way we find our vertex. That's what it's called. So before, the k just told us if we shifted our vertex up or down. And that is not the case for these types of problems. So we've got this plus bx in the middle. So to find the axis of symmetry, so as a reminder, axis of symmetry is what the line that splits the parabola right in half. So to find that axis of symmetry, you have to do a little formula. You do x is equal to, and you do the opposite of your b, so the coefficient in front of x, over 2 times a. Now that equation just happens to be the exact same equation for finding the x value of the vertex. That's because the x value of the vertex will be right on that line. To find the y value, you just plug in the x value and solve. Okay, so we're going to plug it into the equation that you have right here and find your y value. And then y-intercept. So y-intercepts in general, I'm going to put it off to the side. When it comes to y-intercepts, it's always a value where x is equal to 0. So if we have a y-intercept at 6, this coordinate would be 0, 6, so the x value is 0. So the way you find your y-intercept is you plug in 0 for your x. Now if you think about it in this general equation, if I do 0, so a times 0 squared plus b times 0 plus c, that's the same thing. A times 0 squared is just 0, b times 0 is 0, and then we've got plus c. So 0 plus 0 plus c is just c. So the y-intercept is always c, or the constant at the end. So constant means there's no variable on it. And that's why it's always c. Okay, so let's get into some example problems. So we have, for this first one, we want to find our axis of symmetry. So, So the first thing we're going to do is find, label our a, b, and c, because remember it's negative b over 2a. So your a is 2, your b is negative 8, and c is 6. Now it's negative b. B's already negative, so this negative b means to do the opposite of b. So the opposite of negative 8 is positive 8. So I have positive 8 over 2 times a, or 2 times 2. So I would multiply first the denominator. So 2 times 2 is 4, and 8 divided by 4 is 2. So our axis of symmetry is at x equals 2. And we're going to be graphing these eventually, so I'll go ahead and go to 2. So positive 2 on the x-axis is right here. And I'll just go ahead and put a dotted line. Now, a vertex is going to be a coordinate. So the vertex is going to be an xy coordinate, and we already know how to find our x value. We've actually already found it. So our x value is the same as this number, so it's 2. So we need to find our y value by plugging in 2 into our equation. So here's our whole equation. So we have 2 times 2 squared minus 8 times 2 plus 6. You can do that in your head. You can type it in. And when you get your answer, or when you type it in or do it in your head or whatever, you should get negative 2. So I'm going to put that number in for our y value. So if I go back to my graph, I'd go to the coordinate 2, negative 2, and I'd draw a coordinate right there. Okay, last but not least, remember a y-intercept is the value, the y value, where all the x's are equal to 0. And so the easiest way of doing that is you just take the constant, or c, so that's 6 in this case. And a y-intercept, you just go along the y-axis, and I'd go up 6. And there's one of our coordinates. Now, the axis of symmetry tells us we can reflect this over, so we'll reflect it over. And there you go. If they ever ask you to find 5 points rather than just 3, one thing you could do is take the A in front in this case, and I can go from the vertex and go up over 1 up 2. I could also, if I already had those coordinates, I could use a table and just pick a number, so I could plug in -1 and plot that. So there are a couple ways you could find more coordinates if needed. All right, but if you just have those 3, I'm okay with that. So this next one we'll just do with the 3. Okay, so once again, first thing I would do is label your A, B, and in this case our C is 0, because there's nothing added at the end. So axis of symmetry, remember, is -b over 2a. So b is already negative, so I'm going to change it to a positive 6 over 2 times -3. 2 times -3 is -6, so I do multiplication first on the bottom. And then 6 divided by -6 is -1. So x equals -1. Let's go to our graph, and on -1 I'll just put a dotted vertical line, and that's that. Let's go to the vertex. So we know the x value of our vertex is -1. So we'll make a little table. I'll put -1 in for x, and then I'm going to plug it into our equation up here. So we'll do -3 times -1 squared minus 6 times -1. So that will give you a +3 if you plug it in. So I'm going to go ahead and write this, or plot that coordinate. So I'm going to go -1 +3, so left 1 up 3, put a point. And then our y-intercept, remember, is the c value, because that's what you get when you plug 0 in for all of your x's. So c equals 0. So I'll have 0, 0 as one of my points. And then I'm going to reflect it over the dotted line. And just go ahead and make your U shape. Oops.